Hello everyone, welcome back to the channel. Today we're diving deep into one of the most essential and intriguing aspects of our lives, sleep and dreams. Every single night, we all embark on this extraordinary biological journey that influences our physical health, emotional resilience, and even our creativity. Yet sleep and dreaming remain among the most mysterious aspects of human existence. Have you ever wondered why sleep takes up nearly a third of your life? Why do we dream, and what do those vivid, often nonsensical narratives really mean? How did such a vulnerable activity, leaving us unconscious for hours at a time, become so essential for survival? Today, we'll explore the science behind sleep and dreams, uncovering how these processes evolved, how they work, and why they're crucial to our daily lives. Let's begin with the fundamentals of sleep. Sleep isn't just a passive state where your body powers down like a machine turning off for the night. It's actually a highly dynamic and complex process, with your brain and body working harder than you might imagine. Throughout the night, you cycle between two main types of sleep, non-rapid eye movement, NREM, and rapid eye movement, REM sleep. These two states alternate in roughly 90-minute cycles, each playing a unique role in maintaining your health and cognitive abilities. When you first fall asleep, your body enters the lighter stages of NREM sleep. Gradually, you sink into slow-wave sleep, the deepest and most restorative part of the night. During this phase, your body repairs tissues, strengthens the immune system, and clears away waste products in your brain. Remarkably, your brain acts like a janitorial service, flushing out toxins like beta-amyloid, a protein associated with Alzheimer's disease. But that's just one part of the story. Slow-wave sleep is also when your brain consolidates factual memories, helping you retain information from your waking hours. As the night progresses, REM sleep begins to dominate. Unlike the calm and restorative nature of slow-wave sleep, REM sleep is a paradox. During this phase, your brain becomes nearly as active as when you're awake, while your body becomes paralyzed to prevent you from acting out your dreams. It's during REM sleep that we experience the vivid, surreal, and emotionally charged narratives we call dreams. But what's truly fascinating is what REM sleep does for your mind. It processes emotions, helps solve problems, and strengthens your ability to adapt to challenges. This delicate balance between NREM and REM sleep has been shaped by millions of years of evolution. Sleep isn't just a human phenomenon, it's a universal behavior found across the animal kingdom. From jellyfish that enter sleep-like states despite lacking brains, to migratory birds that nap for seconds mid-flight, sleep exists in almost every form of life. But why would evolution prioritize a state that leaves creatures vulnerable to predators and other dangers? The answer lies in the profound benefits of sleep. It's so essential that natural selection preserved it, adapting its patterns to fit the unique needs of each species. Consider dolphins, for example. These intelligent marine mammals can't afford to be completely unconscious because they need to surface for air and stay vigilant against predators. To solve this, dolphins evolved unihemispheric sleep, where one hemisphere of their brain sleeps while the other remains awake. Similarly, migratory birds take micronaps lasting mere seconds while flying thousands of miles. And then there are elephants, which sleep as little as 2 hours a day, balancing their need for rest with their need to stay on the move. Humans, however, are unique. Not only do we sleep for longer durations than many animals, but we also devote a significant portion of that time to REM sleep. Why? It's likely tied to our cognitive complexity. REM sleep is thought to enhance memory, boost creativity, and regulate emotions, skills that are vital for survival in a social species like ours. Early in our evolutionary history, humans made a dramatic transition from sleeping in trees to resting on the ground. This shift, while risky, allowed for longer, uninterrupted periods of REM sleep. Fire played a pivotal role in this transition. It provided warmth, deterred predators, and enabled early humans to sleep in larger, more secure groups. Over time, the cognitive benefits of REM sleep, improved problem-solving, emotional resilience, and creativity, likely gave our ancestors a survival edge. Speaking of creativity, let's talk about dreams. For centuries, dreams were viewed as mystical messages from the gods or windows into the unconscious mind. Sigmund Freud famously described dreams as the royal road to the unconscious, interpreting them as expressions of hidden desires and unresolved conflicts. While Freud's ideas were revolutionary, modern neuroscience has shifted the focus. Today, we understand dreams not as cryptic messages, but as byproducts of neural activity during REM sleep. Here's what happens when you dream. During REM sleep, neurons in the brainstem fire spontaneously, sending signals to the cortex where sensory information is processed. However, because the brain is cut off from external stimuli during sleep, it essentially creates its own sensory input. This is why dreams often feel vivid and immersive, but also strange and nonsensical. The brain is trying to make sense of internal signals in the absence of real-world input. Dreams may feel random, but they serve crucial functions. Studies suggest that dreaming helps us process emotions and consolidate memories. For example, when you dream about a stressful situation, your brain might be rehearsing ways to handle similar challenges in waking life. Dreams also enhance creativity. Throughout history, some of humanity's greatest ideas have been inspired by dreams. Chemist Friedrich Kekulé dreamed of a snake biting its tail, leading to his discovery of the benzene molecule. Paul McCartney composed the melody for Yesterday in a Dream. These examples show how dreams tap into the brain's ability to form novel connections, unencumbered by the constraints of logic. J. Allen Hobson, a pioneering researcher in dream science, argued that dreams are the brain's way of warming up its neural circuits. In his book Dreaming: An Introduction to the Science of Sleep, Hobson explained that dreams reflect the brain's efforts to integrate emotional, sensory, and memory-related information. This process not only helps us make sense of our experiences, but also prepares us to face future challenges with greater emotional resilience. But the story of sleep doesn't end with dreams. The structure of sleep itself changes throughout our lives. Newborns, for instance, spend more than half their sleep time in REM, compared to just 20 to 25% in adults. This abundance of REM sleep in early life is thought to support rapid brain development, laying the foundation for learning and adaptability. As we age, the amount of REM sleep decreases, but its importance remains. Without sufficient REM sleep, people often struggle with emotional regulation, memory retention, and problem solving. Interestingly, the content of our dreams also evolves as we grow. Children's dreams tend to be simple and fragmentary, reflecting their developing brains. In contrast, adult dreams are more complex, often weaving together elements from daily life, long-term memories, and subconscious fears or desires. These narratives can feel deeply personal and emotionally charged, even when they defy logic. Sleep, in all its complexity, is far more than a nightly recharge. It's a cornerstone of life itself, touching every aspect of our physical, mental, and emotional well-being. From the earliest organisms that evolved sleep-like states to the complex dreaming brains of humans, the story of sleep is one of adaptation, resilience, and endless wonder. Whether it's dolphins sleeping with half their brains, birds napping mid-flight, or humans unlocking creative insights in REM, sleep remains a universal phenomenon that unites all living beings. Thank you for joining me on this journey through the science of sleep and dreams. What are your thoughts on today's topic? Let me know in the comments below. I read every single one and love hearing your insights. If you have a specific topic or question you'd like me to explore in a future video, feel free to drop your suggestions. This channel is all about diving into topics that matter to you, and your ideas help shape the content we create together. Don't forget to subscribe, like this video, and share it with someone who might find it helpful. Thanks for watching, and see you in the next video.